Hey guys, you are tuning in to the homework 10 answer key. So we'll go over this. This one's tough. This is the one that was about cross sections, which I think, I don't know, it felt like a lot of people were having a bit of trouble with this, so I'm going to try to help you. But it says for number one, which of the following could represent the cross section of a cylinder? So for this, I'll bring up that website again. Zoop, here it is. Right now it's showing two cones, which isn't what we want, but I can make it show a cylinder. I can make it show a cone. I can make it show a pyramid or a prism. But if we want to explore those shapes, right, then this is a great way to do it. So looking here, before I do anything, I see that shape that we called a truncated ellipse, but that's not one of the options up here. But it will be if I just angle this thing more steeply. Not by doing that, this one here. If I angle this more steeply, then we can get our shape to pass through the top and bottom. So I'm going to move the slice. Yeah, that's fine. I'm going to tilt it some more again. Aren't I? I think I might want it more like over there. Tilted. Ugh, this is not great. Alright, let me show you this. You can't tell. You can't tell what I want to tell from this. And I can't zoom in or out. No, not really. I think I got this working pretty well though. I guess not. I guess that shows the shape I'm looking for. Okay, but not great. Anyway, I'm trying to get you to see that the very last option here is a possible intersection from a cylinder. As long as I use a plane that passes through the top over here on the right, it should come out the bottom over here on the left, so that there's a pretty steep angle between them. And as long as we let that angle be pretty steep, too steep, there we go, I don't know, then you might see that you're getting a top and bottom that are parallel, and then the sides still kind of bulge out with that elliptical curve, okay? So, alright, that took a while to actually explain, but I'm saying that that last shape is possible. I'm also saying a circle is possible. Of course that's possible. That's possible as long as all we do is keep the plane parallel to the base. So that seems to be happening here-ish. No, that's slanty as heck. There. So that's perfectly parallel to the base, which means if we look straight down at it, we're getting a perfect circle. If we move the slice up and down, it doesn't matter. The slice doesn't change. We're just still getting a circle. So that tells me circle is certainly an option, right? Now ellipse is an option too. We saw that as I was trying to do the other one. If I tilt this plane just a little bit, then we can look down at it, and as long as I don't let it pass through the base, if I just let it go through the walls, I can tilt it a little bit more and then just drag it down a little bit more. Then there's a pretty obvious elliptical shape to this thing now. It's not a perfect circle. If we view it straight down, we can see it's not a perfect circle. It's still kind of stretched. So that's a shape called an ellipse. And since it's possible, you'd want to put a check mark on it. Alright, what about this trapezoid? Can I get that? Well, no, I can't. There's no way to get that, because when we saw what we thought would be a trapezoid, we ended up getting this shape instead. Because when you pass through those walls, they're not going to stay straight, they're going to stay bent. Now that's not quite true. I know that those walls will stay bent, will stay straight, I mean, but only if we're slicing exactly perpendicular. So let's tilt this thing again to where we're straight up and down. And then if you look at this straight on, you see we're not getting curved sides anymore, because we're straight up and down on this curved wall. and that is actually going to generate a nice straight cut through that gives us what I assume is supposed to be just a rectangle, but it looks here like it could be a square. Maybe the distance across is exactly the same as the distance up and down. I'm going to call it a rectangle anyway, just in case it's not. And so we'll say, yeah, that's definitely possible. No, that isn't. And no, that isn't. Okay, but we've explored the cylinder about as much as I think we need to. So I hope that's sinking in. Let's move on. This one says describe the shape that results from each cross section. So here, I don't know, you've got kind of a stick of butter. Really, it's more like 2 sticks of butter that are jammed together. And if I take my cross section, I think you can see that right here, cutting across and then going back, we would get a rectangular cross section that's exactly the same size and shape as just the top of this particular prism. So describe the shape resulting. I think all you got to say is it's a rectangle. And that's good enough. So now we're slicing through sort of the same stick of butter, but we're slicing vertically this time. So this time we know that our cross section will be exactly congruent to this front cross section, which is a square. And lastly here, they're showing us a cube that they're cutting on an angle, and they're cutting right here at the corner. So we can see the cross section is going to be a triangle. So there's 3 more examples with cross sections. Now this says, what is the least number of sides that a cross section of a cube can have? So we'll make a cube. There you go, there's your cube. And it says, what's the least number? So I feel like I could get the least number of sides by tilting this on a pretty sharp angle, rotating it towards the corner, and then moving it up and down. So if I make a slice like this, pretty darn close to the corner of our figure, then we see that we can get a polygon with only 3 sides. That's a triangle. Because they said, what's the least number of sides that a cross section of a cube can have? Well, it's definitely 3. And all you got to do is slice off the corner, like I'm showing you guys over here in that lower left-hand corner. You can see that if we slice off a little corner, we get 3. It says now, what's the greatest number of sides that a cross section of a cube can have? Well, for that, think about the sides of a cube, or the faces. If you've ever played a game with a die or a pair of dice, then you know there's 6 sides. The top might be 1, and down here on the bottom would be 6. 1, 2, 3, 4, 5, 6. Then this face over here might be 2. So this face over here would be 1, 2, 3, 4, 5. Then the front face, maybe the front face is 1, 2, 3. Well, then there in the back would be 1, 2, 3, 4. Again, that got messy real fast, but you guys have held and touched a cube before. You know it has 6 faces. So that's also the answer. So what's the greatest number of sides that a cross-section can have? A cross-section can never have more sides than the solid has faces. So the fact that we have 6 faces tells me that the greatest number of sides we could have is also 6. Part C says, what's the least number of sides that a cross-section of a hexagonal prism can have? Well, that's still going to be 3, because I don't really care how many sides we have. If you're trying to get the least number of sides on your cross-section, you're still just going to go to a corner and go slice, 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 cut off a little corner, and say that it has 3. Now, what's the greatest number? Well, let's think this through. We said it's down to how many faces we have. And in a hexagonal prism, we certainly have a base and then a second base. There's 2 hexagons, one on top, one on bottom. So that's 2 faces already, my 2 bases. Then if I have 6 sides, we said that we're going to hang a rectangle off of every one of the 6 sides of the base. So in addition to our 2 bases, we're also going to get 6 rectangles or lateral faces. So it would seem that we have 8 total faces. And that means if someone took a knife or whatever and tried to cut us, creating the most possible sides, the most they could get is 8. That's it. The least is always 3. The most is always however many faces the figure has. So hopefully that's not too bad. Alright, now these are sort of interesting. It says here we're starting with a solid that is a cube, and someone like drilled down into it and drilled out a cylinder. So what would be the cross section? Which of the following is the cross section? Oh, okay. So they mean the cross section that you would get using this plane. Because other planes can definitely make different cross sections, but this one's slicing right through. The way we see it, I hope you guys can tell. But our cross section, of course, will be this thing here, going back, back, back. And that's definitely a square, but now think about the drilling. The drilling is definitely cutting down, and we would get a square with a hole removed from its middle. So the answer for sure is H over here. It should be a square with a hole removed from the middle. And that's 4. So 5 is that same thing, but this time our slicing plane is in a different spot. So notice I could trace, trace, trace. We see that our cross section is a square, except of course for the fact that somebody drilled a hole through here. So actually there's no cross section there at all. Our cross section would only be these 2 bits here on the left and right. So I think it's H again, right? We're getting some wood over here on the left, we're getting some wood over here on the right, but in the middle is just a big hole where they drilled through. So it should be H. Now this says draw a 2D shape that can be rotated about the x-axis to generate a cylinder with a cone subtracted from its volume. Alright, fine. So if I line this up, my bad, not actually ready. If I line this up, okay, so if I line this up, then remember that as we rotate this, there's actually nothing here where the cone is. That's all empty and hollow, right? That's what that's supposed to be. So that means if I'm trying to generate the shape, I really only need this part right here, this right triangle. Because as that thing revolves around and around and around, it's going to leave this cone-shaped emptiness, but it is going to fill in all this other stuff on both sides. We're going to have a round bottom. We'll have, I don't know what to call this. The opposite of a cone? It's a cylinder without the cone? Something like that. Anyway, all you got to do for this one is be able to visualize it. You don't have to draw it. Didn't even ask for dimensions either. So I think you'll be okay. Next. We're done. That was the end of 10. So I'll get to 12 eventually. I might not post 12 until tomorrow because I'm getting pretty tired. Anyway, hopefully these ones helped. Good luck. Talk to me Monday if you have more questions. But I'm out of here. Good night.